In this video, we're going to do a few extra examples, focusing on factoring, but also just performing some operations with polynomials. Okay, so that's what we're going to start with. So in example 1 here, we want to perform the following operations. So in part A, I have a polynomial 2x cubed minus x squared plus 7 plus another polynomial x to the 4 minus 3x to the 3 plus 4x minus 3. So when we're adding and subtracting polynomials, what we want to do is look for like terms. So I can see here that I have 2x cubed and also a negative 3x cubed. And I have a 7 and a 3, those go together, but all the other powers of x's are different. Okay, so this is going to simplify. I'm going to put them in decreasing order, but it doesn't really matter. So I have an x to the 4th, and then I have my 2x cubed minus my 3x cubed. That gives me a negative x cubed. And then I have my minus x squared plus a 4x, because those didn't have any like terms. And then I have plus 7 minus 3 is a plus 4. Okay, so that's performing that operation. Now, when we want to multiply polynomials, so here I have what we call a monomial, so a polynomial with one term, multiplied by a trinomial, so that has 3 terms. So what I'm going to have to do is expand into the brackets. Okay, so this 3x squared, I'm going to have to multiply to each of these 3 items. Okay, so that's going to look like 3x squared times 2x to the 5 minus 3x squared times x plus 3x squared times 4. And then we just multiply the numbers, and then we multiply the x to the powers of x's. So 3 times 2 is 6. And then I have x. Now I have 2 x's times x to the 5. So that's going to be x to the 7. So 7 x's in total. So remember, when you multiply with the same base, you want to add the exponents. Okay, so similarly over here, I have the 3, and then I'm going to have x to the power 3, because I have 2, and then 1 more. And then my last term is I have 12x squared. None of these are like terms, so we can just leave it. One more example of expanding. So here I have 3 binomial terms. So what you want to do is just pick 2 of them, it doesn't matter which 2, and multiply those out. Okay, so we use something that we usually refer to as FOIL. Okay, so that's just a method, an acronym to remember how to multiply these things out. Okay, but if I'm going to do these 2 first. Like I said, though, it doesn't matter what 2 you do. So you do the first ones, so I multiply the 2 first ones, and then I do the outer ones, so I multiply the 2 outer ones, and then I do the inner ones, and then I do the last ones. So that's where the FOIL comes from. So when I do that, I'm going to have x times x, which is x squared, plus x times 3, which is 3x, plus negative 2 times x, so that's minus 2x, and then plus negative 2 times 3, so that's negative 6. And all of that is times 2x minus 1. Now there's like terms in that bracket. Okay, so I'm going to put these together. It's going to make it a little bit easier. Okay, so 3x minus 2x is just 1x. Okay, and now here I have 3 terms, but I do the exact same thing. So I take the first term and I multiply it to both things. Okay, and then I take the second term and I multiply it to both things over here. And then I'm going to take the third term and also multiply it to both things over here. So when I do that, I'm going to have 2x squared times 2x, so that's 2x cubed. X squared times negative 1 is negative x squared. X times 2x is 2x squared. X times negative 1 is negative x. Negative 6 times 2x is negative 12x. Negative 6 times negative 1 is positive 6. And now I just want to combine the like terms. So x squared, negative x squared plus 2x squared is just plus x squared. And negative x minus 12 more x's is minus 13x plus our 6. Okay, so now let's move into factoring. So this was expanding. Okay, that's the opposite of factoring. So first of all, what you want to do is look for things that they have in common. So in this part A, I see that they just have the number 3 in common. So I can pull out the 3, and then what's left in the first term is 5x, and what's left in the second term is just a minus 1. So that's my factored form. In this one, we just want to pull out, again, like terms. So I can take out a 3. There's x's in both and y's in both. Okay, and I always take it out to the smallest power. So for the x's, I have a 2 and a 1/2. So I'm going to take out 1/2 of them. And for the y's, I have a minus 1 and a 3. So I have to take out the minus 1. Okay, so now what's left over, in the first term, the 3 is gone, the y to the minus 1 is gone, and now I used to have x squared, so what's going to be left over is x to the 3 over 2, so that when I multiply in here, 1/2 plus 3 over 2 is 4 over 2, which is 2. And then in the other term, I have a 2, the x's are gone, I took all of them out. For the y's, I took out negative 1y, so I'm actually going to have 4 y's in here. And then we don't usually like leaving negative exponents, so what you can do is actually just drop it down to the denominator. Okay, so that would be factored. Okay, so same idea here. Oops. So I see that there's x minus 1 in both, okay, and the 1 power is the smaller power. And then there's also 3x plus 2 in both. And here I see that the 3 is the smaller power. And I can also take out this 2, okay, because there's a 2 in the 12. Okay, so I'm going to pull out 2. X minus 1 to the 1, and 3x plus 2 to the 3. Now I want to know what's left over. So in the first term, I took the 2, I took the x minus 1, and I took 3x plus 2, or 3x plus 2's. So there's still one more 3x plus 2. In the next term, I took out 2, so I still have 6 left from the 12. All of the 3x plus 2's are gone, but I still have an x minus 1 left over. And now I just want to simplify in that bracket. Okay, so I have 3x's plus 6x's is going to be 9x's. And then I have 2 minus 6 is minus 4. So there's my factored form. Okay, now we're going to try something very similar, but with rational exponents. So I'm going to rewrite this as x plus 4 to the 1/2 plus 1/2 x plus 4 to the minus 1/2. Okay, so you could pull out the x plus 4 to the minus 1/2. That's the smaller power. Okay, and then what's going to be left over in the first term, we're actually going to get x plus 4 to the power 1. So the reason for that is 1 plus negative 1/2 is equal to 1/2. Okay, so when I expand, if I expanded this through, I would be adding these exponents, and I'd want to get that exponent. Okay, so that's where that comes from. And I took all of that, so then I just have 1/2 x over here. Okay, so now just simplifying in the brackets. It's going to be x plus 1/2 x, so that's 3 over 2x plus 4. Now again, we don't like those negative exponents, so this is actually 3 over 2x plus 4 divided by x plus 4 to the positive 1/2. And if you want to get rid of that 2, so that there's no fractions within fractions, we could just multiply top and bottom by 2. and then we're going to have 3x plus 8 over 2, and then you could actually write this as a square root, because it's a 1/2 power is like a square root. Okay, now another way you could have done this instead is to get rid of the negative exponent first. So you have root x plus 4 plus, it's going to be x over 2 root x plus 4 when I drop it down. And then this is like over 1, so you could make a common denominator. So you'd have to multiply this term on the top and the bottom by 2 times square root of x plus 4. Oops, I want to be in green so it looks different. That's going to give you 2 times x plus 4, and then you have your plus x, because now we have the same bottom. And that's going to be 2x plus x is 3x, 2 times 4 is 8, over 2 square root of x plus 4. Okay, and this is the same. Okay, so either way is fine, whatever way you prefer. I like to get rid of the negative exponents first, but either way. Okay, so now when we have a quadratic, so here we don't have any common factors to pull out, but we have a power 2 polynomial. So what we want to do to factor this is to look for 2 integers, okay, that multiply to give the last number, so the 6, and add to give the 5. So 2 integers that multiply, you could write everything that multiplies to 6, but you probably already know it's going to be 2 and 3 are numbers. And then this immediately factors as, because of there's an exponent 1 there, it factors as x plus 2 times x plus 3. Okay, and if you ever want to check, you could just expand it out. So if you do expand the first ones, you get x squared, plus the outer ones is 3x, plus the inner ones is 2x, plus the last ones is 6. And those 2 in the middle go together to make 5x. Okay, so let's try that again. So we want to multiply to negative 12 and add to 1. So when you multiply to a negative number, it means one of your numbers is negative. So I want 2 things that multiply to 12 that are 1 apart. Okay, and that's going to be 3 and 4. Now because I have a positive 1, it means that the smaller one has to be the negative one. So I'm going to have negative 3, positive 4. So that means this is going to factor as x minus 3 times x plus 4. Now it's a bit different when there's a coefficient in front of the x squared that's not 1. Okay, so here we want to multiply to the first number times the last number. And we still want to add to the middle number. Okay, so when they used to call this over the hill. So you take this first number, multiply it by the last one. That gives you the number you want to multiply to. So here we want them to be 5 apart. So it's actually going to be 1 and 6, and the 1 is going to be the negative 1. And now here we don't get the factorization right away. So what I want to do is split up the middle term, the 5x, into 2 terms. So I could write 5x instead as 6x minus x. Or minus x plus 6x, doesn't matter. And then we use a method that they call factor by grouping. So I'm going to group these terms and take out their common factors. Okay, so in the first 2, I can take out a 3x, and then I'd be left with x plus 2. In these next 2, I can take out a minus 1, and then I'm left with x plus 2. And now I see that I have this more complicated common factor of x plus 2. So I can pull out x plus 2, and I'm left with 3x minus 1. So there's my factored form. Finally, here I have 4y squared minus 1. So there's no middle term. And I could actually write this as 2y all squared minus 1 squared. So this you might recognize as a difference of squares. Okay, so there's a formula. So if you have a squared minus b squared, it factors as a plus b times a minus b. Okay, so that means that 2y is like my a and 1 is like my b. So this is going to factor as 2y plus 1 times 2y minus 1. Okay, and that's my factorization there. So that's a few different types of factoring examples.